Good morning.
I broke my phone and
Okay, guys, good morning.
Good morning, Professor.
Any questions regarding practice exam?
I was hoping we can go over some and then if it's possible to go over an example of chapter 2.8 and chapter 2.9.
You have it in your practice exam, right?
Yeah, but is there any way we can go over?
You mean like lecture it again, Victoria?
No, just like a question or, two, just like do it together.
Say one, people asking 1.1 4B 5A 8. Let me just write down this. Okay, number 1. Sketch the graph of a function f for which f at 0 equals 0, f prime at 0 is 2, f prime at 1 is 0, and f prime at 2 is negative 1. So,
Professor, you're only going to go over those problems or the whole practice exam.
If you have a question, you can write it here. So I'll go over the questions that you have written in chat. And
Okay.
then if there is a time, go over the rest of them.
Okay. Okay.
So if you don't have a question, I don't have question either, right?
I mean, no, I mean, I did it. I just want to know I did them right since there was no answer key. That's
Yeah,
why.
those are from the book. You can check it out in the book.
Oh, okay.
Some of them will be like in the class, probably.
Okay.
Okay, now we have a problem. Let's see. There's something goes wrong. Okay, let me see the first problem. It says f at 0 is 0. F prime at 0 is 2. F prime at 1 is 0. F prime at 2 equals -1. So for the number line, at 0, we have first of all zeros. So f at 0 is 0. Nothing else we have it. So we have derivative is 2 at 0. 2 means slope of the tangent line is 2. So 1 to the right, 2 up. So that's the point. So if I draw the now line, should be the tangent line at 0. So that means my graph is here, touches something like this. And because to the left we have nothing, I can even draw this part. So it can go like that. Now f prime at 1 is 0, so that means should be horizontal. At 2 is -1. Now go to the 2. -1 to the left, 1 up. So this should be tangent here. So at 1 we have 0, and at 2 it should touch here. So this just goes up. We have horizontal here, and that's your graph. And this part can go this way, doesn't have to be this way. So at 0, slope is 2. At 2, it's -1. At 1, it's 0. This is number 1.
Professor, I didn't understand how we got the second tangent line that lies on 2.
It says -1, right? F prime at 2 is -1.
Mhm.
How do you find the line with the slope -1? One
Oh,
to the
good.
left, one up. So the point should be somewhere here.
Thank you.
No problem. So the point is here. Draw the line. And the horizontal, we can shift it up and down because it's not fixed. So we can have it anywhere we want. I mean, even derivative at 2 is -1 doesn't have to be necessarily. No, actually it says like at 2. So slope should be passing from here, yeah. But the graph can touch anywhere. No, at 2 it should touch it. Okay, so let's see what's next question. Oh, now we have plenty of them. 9, 11, 6b, 9d, 2.4a. Okay, let's go to the so 2. No, if you mention it or not, something will be there. So it says find the derivative using definition of the derivative. So derivative f of x plus h minus f of x over h. So it's square root 9 minus x plus h minus square root 9 minus x over h. So you need to multiply by conjugate. 9 minus x plus h plus square root 9 minus 6. Same thing is here. So it equals. So numerator would be 9 minus x plus h minus 9 minus x over denominator. So you have 9 minus 6 minus 9 plus x over denominator. So 9 minus 9 negative x h. So you have negative h over h times square root 9 minus x minus h plus square root 9 minus x. So these two divide out, so we have -1 over that. That's number 2. Now, let's see what do we have.
Professor,
Yes,
the h on the denominator, we don't put that to 0.
no.
Oh,
You just need to have an expression. They don't ask you. Oh, you need to, yeah, limit of that, correct. See, it says find the derivative based. Yeah, I mean, I did just like, I do like in pre-calculus, see? So, share this thing again. So, you need to have something, but limit, correct? Limit of f of x plus h minus f of x over h as h approaches to 0. So you should get limit -1 over, so you have square root 9 minus x minus x plus square root 9 minus x, x approaches 0, -1 over 2 square root 9 minus x. This is what you need to have. And you can, of course, use the shortcut. See, it's 9 minus x 1 over 2 derivative, which is 1 over 2, 9 minus x -1 over 2 times 9 minus x derivative. So that's how you're getting -1 over 2 square root 9 minus x. So you need to check your work. You can do it on your own. You don't have to show it there. Domain and range. So find the derivative of the function in the definition of domain of the function and its derivative. Domain of f. So here, domain of f is. So 9 minus x must be greater than or equal 0. So x is less than or equal 9. So it's negative infinity up to 9. Domain of, yeah, just the domain. Domain of f derivative is, see, 9 we cannot have it, so it's negative infinity up to 9, but open. So that's the little bit tricky part here. Okay, now let's see what else do you have. So let's go in order. 4b, 5a, 8, 9, 11, 5 is there, 7, 10, 12, 9d, 3. 3, so 1, 3, okay, let's see. So let's go back to this one. 3 is just finding tangent and normal. So you need to find derivative y prime equals. So you have x plus x 1 over 2 derivative. It's 1 plus 1 over 2 x negative 1 over 2. Now y prime when x equals 1 equals, so this is 1 plus 1 over 2 square root x. So we have 1 plus 1 over 2 times 1. 1 plus 1 over 2 would be 3 over 2. So this is slope of the tangent line. Slope of the normal line is reciprocal with the opposite sign. And then use those to find the equations. So y minus 2 equals 3 over 2 times x minus 1. Add 2 to both sides, so your y equals 3 over 2x. 2 is plus 1 over 2. That would be your tangent line. And y minus 2, this is tangent. Y minus 2 equals negative 2/3. X minus 1 would be normal. So if it's wrong, that's what you do. That's number 3. Any question? No. Normal. It says find the tangent line and the normal. Yeah. So if you have a curve, this is at this point, tangent. The normal is perpendicular to this one. So slope of the tangent is 3 over 2. Slope of the normal, the same point, will be reciprocal with the opposite side. So you need to use 2 different slopes.
Instructor, if the original equation, like the function, would be on a different quadrant, would it still mean the same for us, like a negative reciprocal?
Yes, the quadrant has nothing to do with the slope. Slope is 3 over 2, the other slope is perpendicular to this one. If the graph is here, this is tangent, this is normal. They're always perpendicular to each
Okay,
other.
it's still going in that direction. Okay.
So it should be perpendicular. Now, for B, or for A, what did you say? For A, for A, and for B, someone else for A, someone else for B. Okay, let's go. So derivative, first one, y prime equals derivative of numerator 2x times denominator minus numerator times derivative of denominator 4x cubed 6x over denominator squared equals, so distribute so we have negative 2x to the 5, this to our down, minus 8x cubed and plus 14x over squared. That's the first one. Now for the second one, so this one writes equals x1 third times x squared plus x negative 1 equals, when you distribute, you get x 2 plus 1 over third. So it's 7 over 2 plus x 1 plus 1 third, 4 third plus x negative 1 becomes negative 2 thirds. So now find the derivative. For B part, you have your y prime equals 7 over 2 x 5 over 2 plus 4 thirds x 1 third minus 2 thirds x negative 5 thirds. And you can leave it like that. It's fine to leave it like that. Okay, any question?
Yeah, I was wondering, for the for 4 part, no, for 4B, question B, I tried to use the chain rule, but I don't think it was necessary in this case.
No, if you know, it's not necessary. You can distribute. So 1 third plus 2 is 7 over 2.
Oh, I guess this is a shorthand method to do this.
Yeah, you can distribute and then take a derivative.
Okay, I understand.
No, I distribute it first, combine, and then take a derivative.
Oh yeah, that's
You can, yeah. But then when you simplify it, you should get the same thing. Okay, number 5. We have it, right? Yes. Let's do this one. Yes.
Professor,
Yes.
I have a question. Is there any way we could work on the homework until tomorrow morning before the exam? Like, or let's say until tomorrow at 8 o'clock in case.
You should finish it. No, you need to sleep to get a good sleep. Be relaxed to take the exam. If I allow you to do it tomorrow morning on the homework and you do it, tomorrow you're going to write down. So I didn't sleep all night. I was doing homework, so I'm not able to do the exam. That's why I did really bad on exam. That's why your homework will be due tonight. So you finish it, anything you need to finish, then you relax. Whatever you don't finish, you can make up later. So A. So I told you during the Thanksgiving, I'll open it. So anything is missing, you can do it. So limit sine 3x sine 5x over x squared, x approaches to 0. So this is limit. You can write sine 3x over x times sine 5x over x, x approaches to 0. Now this one, you have limit sine 3x over x, x approaches 0, times limit sine 5x over x. Now multiply by 3, multiplied by 5. So x approaches 0. Now you have 5x approaches 0, 3x approaches 0. So the limit of this part is 1. Limit of this part is 1. So you have 3 times 1 times 5 times 1. It's 50. Now B part. Sine x minus 1 over x minus 1, x plus 2. X approaches 1 equals limit sine x minus 1 over x minus 1, x approaches 1 times limit 1 over x plus 2, x approaches 1. Now x approaches 1 means x minus 1 approaches 0. So the first one becomes 1 times 1 over 1 plus 2. So this is 1/3. So again, if x approaches 1, x minus 1 approaches to 0. You can make a substitution. You can let t equals x minus 1 if you want it. And then you get limit sine x minus 1 over x minus 1, x approaches 1 is the same as limit sine t over t, t approaches 0, which is 1. But if you do whatever I did, as long as you mention it here, this is fine. So you don't have to do anything extra. So any questions? So 5, we did 7. We'll do number 7 is. Take a derivative on both sides. So derivative, derivative. So y prime cosine x plus y times negative sine x equals derivative 1 is 0. Sine xy derivative is cosine xy times xy derivative, which is 1 times y plus x times y prime. So we have y prime cosine x minus y times sine x minus y times sine x equals y times cosine xy plus xy prime cosine xy. Now move this to the right hand side, this one to the left hand side. So let me do this. So you have y prime cosine x minus xy prime cosine xy equals y times cosine xy plus y times sine x. Now factor out y prime, so you get y cosine xy plus y sine x over cosine x minus x cosine xy. Okay, any question? Okay, no question. Next is,
Professor, I asked on number 6. We're gonna do that after?
no, I didn't
6B.
see it. There is no 6 here. Oh yeah,
Yeah, I
6.
heard 6B.
Okay, 6B. So cotangent squared 4x plus x bar derivative equals 2 times cotangent 4x plus x to the 5 times, what's the derivative of cotangent? Negative cosecant 4x plus x to the 5 times derivative of 4x plus x to the 5 derivative, which is 4 plus 5x to the 4. So you have negative 2 times 4 plus 5x to the 4. It doesn't matter the order. Cosecant 4x plus x to the 5 times cotangent 4x plus x to the 5. Now, cosecant is 1 over sine, cotangent is cosine over sine, so it doesn't simplify, you can leave it like that.
Thank you.
No problem. Number 8. Okay, let's do it here. So you have x to the 4 plus y to the 4 equals a to the 4. So first derivative, 4x cubed plus 4y cubed times y prime equals 0. Y cubed times y prime is negative 4x cubed. A is constant. So y prime is negative 4x cubed over 4y cubed. So y prime is negative x cubed over y cubed. So this is equation that gives you relation between the first derivative and x and y. Now, y 2 prime equals negative x cubed over y cubed derivative. Negative states 3x squared y cubed minus x cubed times 3y squared times y prime over y to the 6 equals negative 3x squared y cubed minus x cubed times 3y squared times, so negative x cubed over y cubed instead of y prime, y to the 6 equals negative. So you have 3x squared y cubed plus 3x cubed times y squared is gone. So you get x cubed over y to the 6. Actually, I could have multiplied. It's 3x to the 6. It's okay. So let's multiply by y. So you have negative 3x squared y to the 4 plus 3x to the 6 over y to the 7. Now factor out 3x squared, so you get y to the 4 plus x to the 4 over y to the 7. But x to the 4 plus y to the 4 is a to the 4, so it's negative 3 a to the 4 x squared over y to the 7. That's number 8. Okay, any question? No question. Let's go to number 9. So let's see what we have. So some of the questions easy, some of them require work. Okay, so the question is 9D, but it's okay, we can do all of them. So you have example in your lecture notes, you have example in the book. So velocity, the particle moves according to the law of the motion of t is measured in seconds, s is in feet. So starting from Vt equals f prime t, which is 3t squared minus 24t plus 36, which equals, if you factor out 3, you get t squared minus 8t plus 12. So 3t squared, 24t plus 36. 3 times 8, 3 times 12. This one even can be factored out into 3 times t minus 2, t minus 6. Okay, what is the particle at rest? So that means Vt must be 0. See, in a factored form, you can tell already t equals 2 seconds. T equals 6 seconds. At those points, it's at rest. So velocity equals to 0. Find the acceleration at time t and after 3 seconds. So at is v prime t, which is 6t minus 24. Let's put this way, t minus 4. Now, acceleration after 3 seconds would be 6 times 3 minus 4, which is negative 6. Okay, will be feet per second squared. When is the particle speeding up? So you need to draw two number lines. One for VT, one for AT. Okay, so let's start for both of 0. VT becomes 0, it's 2. So this is 2. This is 2. 6. For AT, we have 4. So this is 4. So we have VT, AT. VT is positive when it's greater than 6. So it's positive here. So let's put something here. It's negative between 2 and 4. So if you plug 3, you plug it into this one. That's your VT. So you have negative, then you have positive here. Now 80. Now plug into this one. Greater than 4 is positive. Less than 4 is negative. Now speeding up. Speeding means V and A must have the same sign. So 0 to 2, they do not have the same sign. So they have the same sign when 2 is less than t less than 4, or t is greater than 6. So that's how you determine it's speeding up if it has the same sign for acceleration and for velocity. Otherwise, it's slowing down, basically braking. Oh, it's here. T equals 2, t equals here. T equals 6 becomes 0, right? That's your VT. Zero, t is greater than 0, yeah. This is A, this is V, this is A. So when you find VT and you find AT, then you're using those equations. No problem. Now 10, 11, 12, let's see if we can make all of them. Okay, cylindrical tank with radius 5 millimeters is being filled with the water at the rate of 3 millimeters and find how fast the height of the increasing. So if it's cylindrical tank, so you're putting the water in it. So let's say this is one level, then it goes to the higher level. So volume is increasing, height is also increases, right? It goes up. Now, volume equals pi r squared h. Radius is given to you, it's constant. Okay, and dv dt is given to you. It's 3 meters, cubic meter per minute. dh dt is a question mark when r equals 5 meters. Take a derivative, so dv dt equals pi r squared times dh dt, because r is constant. So dv dt is 3 equals pi r squared dh dt. So dh dt equals 3 divided by r is 5 squared. So it's 3 over 25 pi meter per minute. That's the rate of change of the height. So height is increasing in this way.
So would we just leave it like that fraction?
Yes,
We wouldn't
you don't have
simplify.
to round it or like use a calculator. Leave it like 3 over 25 pi.
Okay.
I don't really understand why you decide to take the derivative without taking the derivative when r's when it should be pi, 2r.
No, r is constant.
R is a constant.
Yeah, look at the cylinder. The water goes up, the circle doesn't change, right?
Oh, okay.
R is constant. Only thing that changes is h, because it increases. It goes up. So volume changes and height changes. Radius stays the same.
Oh, okay, I understand.
So all of them are function of t. V changes with respect to time, h changes with respect to time. So it's dv dt, dh dt. R is constant, that's why. No problem, R stays constant. So when the water increases the level, height is changes and the volume, but R stays constant. Okay, now let's see 11. This one we did. I think we have it. Spotlight on the ground shines on a wall 12 meters away. If a man 2 meters tall walks from spotlight towards the building at the speed of 1.6 meters per second, how fast is the length of his shadow on the building decreasing when he is 4 meters from the building? Okay, so you have, let's assume this is the ground, this is the building, this is the person. So that's shadow. When the person gets here, see, that's shadow. So this distance changes here. See, this is x becomes this, and this one changes. Was this now becomes this. So let's assume this is x, this is y. So you have x, this is 2, the total is 12, and this is y. We need to have a relation between x and y. So those are similar triangles. See, right triangle, right triangle. So y over 12 should be 2 over x. So y equals 24 over x. Now y and x, both of them are functional time. So it says the person, man, 2 meters tall, walks from the spotlight toward the building at the speed. So dx x dt is 1.6 meter per second. We need to find dy dt. Now take the derivatives. So you get y prime equals, so this is 24 times x to the negative 1. So you get 24 times negative 1, x negative 2 times x prime. So your y prime equals negative 24 over. Okay, so x squared goes here times x prime. So it equals negative 24 times x prime is 1.6. X is, says, when he is 4 meters from the building, if this part is, say, if this is 4 meters, that means your x is 8 meters because total is 12. So I need to use for x 8 meters. So y prime equals negative 24 times 1.6 over 8 squared. So whatever you get will be, so what is it? Negative 0.6? Let me check.
Yes.
Okay, 0.6 meter per second. So it's decreasing. So the length of this length of his shadow is decreasing at the rate of 0.6 meter per second. It decreases to that rate.
I don't fully understand where 4 meters, where
It's
it's
4
decreasing when he is
meters
4
from the
meters.
building. See, when he is 4 meters from the building.
Oh, I see. So like,
The total is 12, right? So the person would be, so your x is this distance. So
so
if,
if the total is 12, right?
correct. So this is,
I don't know how that helps you.
this
But
is 12. So
yeah.
he reaches to this point, this is 4 meters. But x is this part, so it's 8 meters. X is the distance the person is walking towards the building. It's not the
Yes.
distance from the building to the person.
Oh, okay. So wait, where did you get -1 from, or how did this even happen?
Negative x
1.
in denominator. When you take it to the numerator, it becomes x to the negative 1.
Oh, so this is just something that you did to help you find the derivative. Okay,
Correct.
that's
Yeah.
that's simple enough to understand.
Mhm.
Uh,
Number 12. Find the linearization. So linearization is basically you're finding the tangent, right? So L Lx equals f at a plus f prime at a times x minus a. Now f at 16 equals 16 to the power 3/4. This is 8. Now f prime of x is 3/4 x negative 1/4, which is 3/4 root of x. So f prime at 16 equals 3 divided 4 times 4 square root of 16, which is 3/8. So Lx equals 8 plus f prime of 8 x minus 16. We can distribute 16 divided 8 is 2. 2 times 3 is 6. So you get 3 over 8x plus 2. That's the linearization. Any question? Yes.
So what you had to do here was find. Wait, so x is
It's basically tangent line.
x
Yeah.
is here.
And just find
Basically, what
tangent.
tangent?
Tangent line. Yeah.
And so minus 2a. Oh, so yeah, you just simply find the derivative and plugging these values into the equation. Okay.
Yeah, if the, so let's say what would be 16.1, you just put 16.1 and find the value.
Okay, that's simple enough to understand.
Let me look at your questions. So 3, 9, 11, 12. Okay, any other question, guys? $13. Yes, we can do it. So for 13, you're going to use the same linearization. See, first identify the function. F of x equals x to the power 4. A, we can choose 2 because it's easy. So f of 1.999 is approximately L of 1.999. But Lx equals f at 2 plus f prime at 2 x minus 2. So f at 2 is 2 to the power 4, that's 16. F prime of x is 4x cubed. So f prime at 2 is 4 times 2 to the power 3, which is 8 times 4 is 32. So you get Lx equals 16 plus 32 times x minus 2. Now we need to find f 1.999, which is approximately L 1.999, which 16 plus 32 times 1.999 minus 2 equals 16 plus 32 times negative 0.001, which is 16 minus 0.3, right? 0.32, I think. Okay, minus it's 15.96. This is 15. 968. And we're done. Any other question? So try not to be late tomorrow for the exam. And another announcement for you, no class on Thursday because I have an appointment with the doctor, so I will not be here. So Thursday, you will have off. So tomorrow exam, Wednesday we'll have a lecture, and Thursday we're not going to have anything. If you will have more questions at 11, I'll have office hours.
Okay. Thank you very much. I have to tell you, so I was able to get extra time for
Yeah, you will
the
get
exam. And another thing is for the practice exam, if I turn it in tonight, will I get any credit for it?
So you should have done it and you should have turned in when? Yesterday, right?
Yeah.
So you should have done it. Okay, turn it today. I'll look at it and I'll decide. Yeah.
Okay. It's because I did half the questions there, and some of them are very time consuming. That's another thing. I don't know if they're going to be like that in the exam.
So exam will be similar. The one you have it on your practice exam. A little bit maybe different, but generally will look like that one.
Hmm.
Mr. Borosian, I came late and I have 2 questions for the math. If any chance you have number 4 and 6, can I please see it?
6? No, I did it. Yeah.
4 and 6.
Yeah, I think I did both of them, but I don't have it. Constant and for both of them I did. Yeah.
Oh, and for the first question on this one, right?
Yeah.
How did you? So you found the graph, and I'm able to find a derivative, but there isn't enough information to find the original function.
No, it's in. They don't ask you to find the original function. They ask you to graph it. Graph any function that satisfies to those conditions.
Oh, graph any function?
Yes, any function that satisfies to those conditions.
Yeah, but how would you graph that though? It's just
I did that, Diego. So you're late also. Now, I'll come to the office hours and I'll do it. So both of you, Ani and you, Diego.
it's
So
yeah. I
this
only
one is
need
easy. Just 1, 2. So you put the points.
Yeah.
0, you have it. So it should be slope 2. So 1 to the right, 2 up. This is 1 tangent. At 2, you have negative 1. 1 left, 1 up. So this is second tangent. And at 1, you need to have 0. So your graph has this shape. Touches here. At 1, it should have horizontal. And it touches here, goes this way. And at 1, you have horizontal. All conditions are satisfied. Now, 4 is long. The only thing I can tell you on it, the second
no.
one,
I already saw how to do 4.
not you. Yeah, you're
Oh,
not
sorry.
the one there. Yeah, there's another person.
Okay.
X 1/3 x squared plus x negative 1. So you distribute, you get 7/3 plus x 4/3 plus x negative 2/3, and then take a derivative. So your y prime would be 7/3 x minus 1 is 4/3 plus 4/3 x 1/3 minus 2/3 x minus 5/3. But the first one is a little bit long. Y prime would be 2x times x to the 4 minus 3x squared plus 1 minus x squared plus 2 times x derivative of denominator, which is 4x cubed minus 6x divided denominator squared. Now numerator distribute, combine like terms, you get, I don't know, 2x to the 5, and then x squared or x cubed was gone. You have plus 14x, something like this. And let's say, what else do you get? This is x cubed, something like that. I don't remember the numerator and the denominator squared. So just distribute and finish it. Sixes, chain rules. Find the derivative. First one is negative cosine. Derivative would be negative sine a cubed plus x cubed times 3x squared. Second one is 2 times cotangent 4x plus x to the 5 times. Here is this. So close it. Derivative of cotangent, which is negative cosecant 4x plus x to the 5 times 4x plus x to the 5 derivative, which is 4 plus 5x to the 4. So that's what you get. Negative 2, 4 plus 5x to the 4, cotangent 4x plus x to the 5, cosecant 4x plus x to the 5. That's what you get for 6.
Professor,
Yes.
yesterday when I was submitting the practice exam, I had to do it a couple times. I just want to make sure when you open it, you're able to see my work that was submitted.
I allow like, I think if I'm not mistaken, 3 times.
Yeah, that's right. But you were able to see it, correct?
I don't know. I haven't checked it yet. If I see it, then you'll see like your points that I received it. If I don't see it, that means no points, comment.
Well, I sent it. It's just like I had to do it several times. And I think only one of them I was able to upload. I had like my phone crashed, well, broke. I have phone issues now. I want to make sure, you know, when you open, you can see it.
Okay. Let me see. Okay, so any other question?
Oh wait. Oh, just something regarding question 1, right?
One?
No. Question. Well, number 3. Like, if you go to the practice exam, right?
If you go to the practice exam, yes.
See question 1, right? No. Is
Which
there
one?
a way to find the inverse derivative of this function? Because if you can do that, you would be able to find what f of x is, right?
No, not inverse derivative. Inverse derivative you didn't learn. Didn't
Wait,
start
I
with
didn't.
calculus 2.
I didn't learn that.
No, there is no
I mean, I don't
inverse
know if it's
derivative.
possible to do that, but
It's possible, but you don't need to do that.
no.
No, which problem you're talking about?
Oh, just number 1, because you graphed f of x.
I told you it could be any f of x as long as it's satisfying to those conditions.
Oh, well,
So it should pass through the 0. So tangent should have a slope 2 at 0. Tangent at 1 should be 0. Tangent at 2 should be negative 1. That's it.
tangent of 2, right?
Hmm?
Oh, it should be tangent to those lines. I get it.
Tangent is 2. Tangent is 0. Tangent is negative 1. The only thing it says f at 0 is 0. That's it.
Okay, well, have a good day. Bye.
How do you get what?
No, have a good day.
Oh, you too.
Later too.
Yeah.
Mr. Borosian, thank you for doing it, but I have a question for number 5, A or B, if you can do it. Just
No, you come to the office on it.
Yeah.
If you have any question, I'll go over there.